So let's illustrate what we just learned by writing a hello world program of sorts in the C programming language. So the first thing we're going to do is we're going to include the pthread header, and this is for POSIX threads. Basically, POSIX threads is a standard. It pretty much just describes a set of common APIs that you must implement, and the pthread header for C tends to be one of the best implementations of POSIX threads, in my opinion. It's very feature-rich. It's relatively low-level, although C is technically a high-level language. It's a bit more low-level and closer to bare metal than Python, which is one of the primary reasons I've decided to use C for the content in this series. I think that Python just abstracts things away a little bit too much, and we're really trying to understand threading in depth here. So we're going to pull in POSIX threads. We're also going to need the standard IO library. We'll need the standard library, and we'll need the Unix standard header. And this is going to be for pause and sleep. So just a quick call out here. The pthread library, again, it's really feature rich, but we're not going to be leveraging the entire feature set right off the bat. The way this series will work is I will introduce certain concepts to you, then we'll look at it in code, and we'll kind of polyfill the rest of the parts just with things that are easy to digest. So for example, we're going to use pause here to wait for the thread to execute in the main function. Typically in a production grade application, you would actually use either a joinable thread or a detached or daemon thread. But since we haven't learned about those yet, we're not going to be using them. So then we're going to implement our main function. And as you'll remember, the main function is also the main thread. So when I compile this with GCC in my shell, what's going to happen is the process in which my shell is running is going to send a system call to the kernel called fork. And it's going to tell the kernel, hey, I want to execute this program I just compiled. Can you fork a new process? And the kernel is going to replicate the current process that the shell is running in. It's going to replicate that process. It's going to fork a child process. And in that child process, there will be a single main thread running the main function of this program. And this main function is that unit of execution flow that we talked about. It's going to be this set of instructions, all the things that are happening in here. Speaking of which, the first thing we're going to do in the main function is we're going to call a thread create function that we have yet to implement. We're going to print that we have blocked, so we can just see this for illustrative purposes, and then we will call the pause function. So let's go ahead and implement this thread create function. The return type will be void. The first thing that we're going to need to create a thread is we need this pthread object. And you'll note that this is an opaque object. And what I mean by that is there's a sort of design pattern that you'll see very often in C libraries called the opaque pointer pattern. And basically what the library implementers do is they have some sort of struct that they've defined, and they want to expose it to consumers, but they don't want you mucking around with the internals. And since there are no private fields in C, what they do is they will create a new type def and point the internal struct at that exposed struct, if you will. And that effectively makes the fields read-only, so that way you can't really mess with them or you won't see them in your IDE, etc. So that's really their way of signaling to us, this is an opaque object, do not worry about the internals, it need not concern you. There are ways to manipulate those internals, but the POSIX thread library gives us those as APIs, and we will see many of those. Okay, so the next thing we're going to do is we're going to create the thread and schedule it. So we're going to call pthread create. We're going to pass the address of that thread object. The second argument is called pthread_t. This stands for pthread attributes. And just like I mentioned about this opaque object that you don't mutate it directly, this would be one of the ways in which you can modify a thread. There's also a special function for setting thread attributes, but this is all stuff that we'll look at in future videos. For now, we can just pass null. This third argument is going to be a function. We'll call it thread routine. We need to implement it. And this is going to be a function that is essentially the execution flow for the thread. So when this thread executes, it's going to be this function that the CPU is scheduling to run. and we'll implement that in just a second. The fourth and final argument is the state that you can pass to this function. So this function can take an argument. It will be a void pointer. We'll call it thread_arg. And then finally, we're going to make sure that this is not equal to 0. And if it is, we have an error, and we're going to call exit. Quick call out here. You'll notice pthread does not use errno. So if you're a C programmer and you're used to checking errno, none of the pthread functions are going to set this errno value. Instead, all pthread functions return special error codes and 0 on success. So we always just check if it's not 0. This right here is where we're creating a thread. This is called a fork point. And it is not to be confused with the fork system call. So this is not fork. We're not creating a new process. We are creating a new thread. Now, before we implement thread routine, we should make this thread argument to pass in. And I'm going to declare a static car pointer. And there's a really specific reason that I'm using static here. Okay, so this is incredibly important. If there's one thing you take from this video, I hope it is this. You can pass state to a thread, but you cannot pass caller's local state or stack memory. Now you'll remember the resources that we create with a process, and then there's also the execution context that we create for a thread. Now the heap memory will be accessible, static will be accessible to the thread, but the stack will not. You can't pass the caller's local state or stack memory because when we create threads, threads cannot share stacks. So each thread, part of its execution context is it has its very own stack and its very own local state. So everything inside this thread routine function, anything that's defined in the thread routine function, and anything in the thread routine stack, that memory cannot be shared. What we can share is static memory or heap memory. So here we're going to declare a static car pointer, and that's what we're going to pass in to the thread. So I'll mention this. Must be heap or static because each thread has its own stack, part of the execution context. Cool. So let's go ahead and implement this thread routine, and then we can compile and execute the program. So this is going to be also void pointer. We're going to take in that void pointer argument. And then once we get this, let's go ahead and cast it to a car pointer. Now we're going to do an infinite loop here, and we're going to print this argument. And then we'll sleep for 3 seconds. So let's go back down to main, open up a terminal. I'm going to use GCC. And keep in mind here, you may need to link the pthread library. I'll just do that for demonstrative purposes. Okay, so when we execute this main binary, what's going to happen is the shell, the process the shell is running in, is going to send a system call to the kernel called fork. It's going to tell it to create a new process in which we will execute this program. First, we'll start with the main function or main thread. And then the main thread is going to call thread create, which is going to schedule this thread. And then it's going to block on pause. And you'll see that this thread will begin executing at some arbitrary, seemingly arbitrary point of time after we call thread create. So let's go ahead and execute. So we see it's blocked, and now we're seeing the thread ID being printed. In the next video, we're going to talk about joinable threads, and then after that, we'll learn about detached daemon threads. Thanks a lot, everybody. Make sure you like and subscribe if you enjoyed the video. See you next time.